Hi everyone, this is Uday. Today I'm going to tell you about fluid kinematics and fluid dynamics, which is a part of FMHM, which is fluid mechanics and hydraulic machines. So when coming to the fluid kinematics, we all knew that the kinematics is a branch of science. So I'm going to highlight this with the red color. So kinematics is a branch of science which deals with the motion of particles without considering the forces acting on it. Suppose, let me say, there is a vehicle, a car. No, I'm not a good artist, but I'm trying very best to explain. A car, and imagine a person was pushing it from the back face. So in kinematics, this science, the kinematic science tells about the motion of the car here in this example, but it will not consider the person who is pushing the car, and indirectly he is applying the force, which tells us from the figure. So kinematics is a science which tells about the motion of the particles. Here the particles or specimen or object is car without considering the forces acting on it. So if the person is acting on the car, so he is a force, but kinematics will neglect him and only see about the acceleration, velocity, blah blah, or something, which scientific terms we will see later. So when coming into the normal kinematics and into the fluid kinematics, we will see about the liquid and their flow. And similarly, when we go into the fluid dynamics, so let me move this around. And fluids dynamics is also similar to kinematics, but in this case of fluid dynamics, it is a science which deals with the motion of the particles while also considering the forces acting on the object or the particles. So unlike in kinematics, dynamics is a branch of science which explains the motion of the particles or object or specimen. Here about the car is an object, or it is better to call as particles. Don't take this example. I was telling this example for you to understand very well the best. So imagine the car is a particle. Dynamics is a branch which will also consider the forces acting on the car. Here the person who is pushing it is a force acting on the particle called car. So kinematics neglects the force acting on the object, and dynamics also consider the force acting on the particles. Now, to study the very best about fluid kinematics and fluid dynamics, we need to learn about the There are 6 types of flows in fluid. First one is steady and the second one is uniform and non-uniform flow. My writing will be not so good while using mouse to write. Uniform Sometimes I pause the video while I writing because it is inconvenient for me and you to take the long time to see the video. And the third one, which is laminar and turbulent flow. And coming to the fourth one, it is compressible and incompressible. And the fifth part goes to rotation and at last the sixth one, which is 1, 2 and 3D flow, which is a one dimensional and two dimensional and three dimensional flows. You may not see anything about this last sixth part about in my videos, that is 1, 2, 3 dimensional flows in my videos, because that doesn't cover my syllabus anymore and I don't know about them. So let us have a look once again. So we'll learn about the fluid kinematics, and which is the term considered about the forces, and then fluid dynamics, which consider the forces which are acting on the particles. And coming into the fluid types of flows, there are 6 types of flows, which is steady and unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotational and irrotational, and at last be one dimensional and two dimensional and three dimensional flow. Now let us see one by one about each thing. So when coming to the steady and unsteady, these depends upon the properties, fluid characteristics like velocity, pressure and density. I'm going to write it over here. So it depends upon velocity, pressure, and density. So what I said is steady and unsteady flow is a type of flow depends upon the 3 properties of the fluid, with the velocity, pressure and density. Um, so how we tell is that uh, these 3 properties of a fluid does not change with the point of time. At a point do not change with the time, that is known as a steady flow. And if velocity, pressure and density at a point change with the time, then it is known as unsteady flow. Since they are changing with respect to time, they are unsteady, so it is known as unsteady flow. So when coming into the steady flow, the 3 equations can be given for velocity, pressure and density by writing as dou v by dou t is equal to 0. This is for steady flow, and here we can write x naught, y naught, z naught is equal to 0. And for the pressure we can write as I will copy and paste it, it will save time. Okay, for pressure we can write it as dou p by dou p by dou t is equal to 0. And similarly for the density we can write it as dou rho by dou t, which is again equal to 0. And we can suffix as x naught, y naught, z naught is equal to 0. For unsteady flow, since they change with the time, they should not be equal to 0. I mean, velocity should not be equal to 0, pressure should not be equal to 0, and as well as density should not be equal to 0. So that's about steady and unsteady flow. And next, going into the uniform and non-uniform type of fluid flowing, uh, it is the type of flow in which the velocity at any point of time does not change with respect to space. Here the only property is velocity, and at any point of time it should not change with respect to time. So its equation can be given by what they mean is the velocity at any given point should stay there and it should not move in the space. So it is known as uniform fluid flow. Its equation can be given as wait a minute, I have to change this to brush. Dou v by dou s should be equal to 0, and t is constant. And if the velocity at any point of time, if it changes with respect to space, then it is known as non-uniform flow of fluid. So it will not be equal to 0 in case if it is a non-uniform flow of fluid, and it will be equal to 0 when it is a uniform flow of fluid. So that's about uniform and non-uniform. And next, after completion of steady and unsteady flow and uniform and non-uniform flow, the next thing is laminar and turbulent flow. Okay, let me write it over here. So laminar and turbulent flow depends upon a number which is called Reynolds number, which is I think the spelling might not be the correct. I don't know about the spelling. This number depends upon viscosity and velocity and diameter. I mean, a cross-sectional area of the fluid which is flowing. Viscosity in the sense here kinematic viscosity, and if the Reynolds number is less than 2000, I mean Reynolds number is less than 2000, then it is equal to, then it can be say as laminar flow. And if the Reynolds number is greater than 4000, we can say the type of flow is turbulent flow. So in a laminar type of flow, the fluid usually moves in a straight line. So this movement of the straight line is sometimes referred as stream or streak. In turbulent type of flow, particle fluid moves in the zigzag motion. In case if the Reynolds number lies between 2000 and 4000, and I mean we know that if the Reynolds number is less than 2000, then it is laminar. If the Reynolds number is greater than 4000, then it is turbulent. So what about the middle part over here? If the fluid's Reynolds number lies in between the middle, then the flow is called transition flow, and this transition flow is again defined as a laminar or a turbulent flow according to the nearest possible number, either 2000 or 4000. suppose we have the Reynolds number as 2500, which is nearer to 2000, then it is laminar type of flow. The liquid fluid is considered as laminar flow. And if the Reynolds number is about like 3500, which is nearer to 4000 than when comparing to 2000, then the type of fluid is known as a flow of fluid is known as turbulent type of flow. So that's about the steady and unsteady, uniform and non-uniform, laminar and turbulent. Next, going into the compressible and incompressible. If the attraction gap between the molecules is very large or high, then it is known as compressible. So it is defined. It is explained by Lagrangian. It is also called as a compressible is also known as pneumatics, and incompressible is also known as hydraulics. We are mostly see about compressible fluids. The best example for this is if you fill a balloon with some huge amount of air, it can handle in water, but whereas inside its density of the balloon. But if you pour a little bit higher amount of water in a glass of water, it cannot handle the density. So gases have the compressible property mostly. Since it is proposed by Lagrangian, it is also called as pneumatics. And incompressible fluids are proposed by Eulerian. It is called as hydraulics. It depends upon the attraction gap between the molecules. And after the compressible and incompressible, we see about rotational and so when the fluid is flowing, if it is moving in the straight line or a streak line or a streamline, then it is said to be rotational. If it is moving in the zigzag motion or something similar like that, it is known as irrotational. That's all about for now, and I tried my best level to explain. I too don't know about very depth. I also started to learn much more. So that's about types of flows, fluid kinematics and fluid dynamics. And I don't know about the 1 to 3 dimensional flows. It is not in my syllabus. So that's about the introduction of fluid kinematics and fluid dynamics, which is a part of FMHM. I mean fluid mechanics and hydraulic machines. This is Uday signing off, and thank you for watching my video.